Hello, this is another episode from HydraBlend Technologies. It's another update video from my current progress in the HydraBlend. Okay, I think it's recording. So in this past week, I did a infrastructure upgrade. I actually delivered some new servers into my testing server, my test development server. So basically, I've done an Oracle DB installation on CentOS 7 prior, and after doing some research, I realized that they actually stopped supporting for CentOS up to CentOS 8, and the deadline for that is 2021. Which is this year. So I decided to do an infrastructure upgrade into the best distribution to support Oracle SQL, and which is going to be with Oracle Linux actually. So I also thought it would be a good matchup to try to link Oracle dependent resources into Oracle services. So I did a infrastructure upgrade into Oracle DB, into Oracle Linux 8, and did a web server upgrade from Tomcat 9 to CentOS Stream 8. So CentOS Stream is taking over for CentOS development projects. And I think there's some issues with CentOS and Oracle DB in general. Like there's some issues with supporting dependencies with the new Oracle database drivers and stuff like that. So opening up a listener in CentOS 7 seems to have some issues maintaining the session and stuff like that. So for my production deployment, I'm yet to figure out exactly if I'm going to be using Oracle Cloud DB or whether I'm going to scale in infrastructure cloud and just do the manual installation and the support for Oracle DB myself. So for this particular project, undecided on the production deployment, but I'm still test development. I'm trying to upgrade my infrastructure to the latest resources. So what I've done in the past week was upgrade my virtual servers into the new infrastructure services. So that task is done, and this task is pretty tedious. It takes some time to really get this up and running. So I did a full installation, and I did a I ran some backup post scripts to maintain my my database structure, and also and also the installation itself. It takes some time, so it's pretty pain in the ass work on infrastructure. So yeah, that's what I did over the weekend actually. So yeah, I have less time for this. I'm actually working, so my personal project updates are going to be a little bit slower, but I will continue working on it as I move along. So so this is my latest task I've delivered, and let's just mark that as complete. Database design. Okay, so redesigning. I did a DDL structure for reconnaissance engine in external reconnaissance module. So the whole idea with the prior FTP service that was developed and tested was that there's going to be a service that's going to pick up CSV files and process them, and the process is going to update the status of these CSV files. And while it does that, and the whole idea is that this process is going to check the data, like crunch the data, and dump it into an Oracle SQL for analysis. So that is the task in the database design, and that's the work that I've been doing. Okay, so just to give like a little updates for that particular. Let's go into my virtual server. So my virtual server here, I'm using a KVM, pure Linux-based virtualization. So basically, this is the work I've done. Prior video, you might see that I'm using a Lin07, which is a CentOS 7 server for my DBS connection, and I have a web server as well, which is the instance which I'm running my API service. So this server resource has been migrated into Cent OS stream. So I'm going to go ahead and delete this. The beautiful thing about this migration is I love Apache Tomcat. Tomcat is is a very convenient resource to work with, and I'll explain why. There seems to be some technical difficulties and slowdown in here. Apologize for that. I'm a very impatient person, I'll be honest with you. So I can never do infrastructure work. I like development work because, you know, the speed of me typing works with the speed of me developing programs, so it's more convenient. Infrastructure, you have to sit there and wait for things to load on screens. I hate that stuff, man. It's a pain in the ass. So, and it takes a long time, you know. Okay, so it just seems to be like a GUI refreshing situation where the team viewer is not really updating with the you know, the GPU, or it could be like a, you know, it could be a network issue, or it could be something with the services running. But let's just assume it's a network issue, and so here we go. We have the DBS instance. I have a listener running. I don't know what kind of details are in this if I log in, so let's take a look. Okay. One, two. Yeah, okay, that should be it. Okay, alright, so there we go. I have a active listener running, and I filtered everything through firewall requests firewall. So request per firewall. So I have the Oracle instance running, and yeah, you know, like it's pretty good. It's pretty stable, I guess. It's more stable than my prior installation, it seems. I haven't done a full restart yet, but the issue with the CentOS 7 is that every time you restart your Oracle instance, especially the Enterprise Edition, or I haven't tried the standard one, but if you were to test your service on CentOS 7, every time you do a DB restart, it loses the connection to the listener. And whatever configuration you put into the TNS listener file, it doesn't seem to pick up the listener or update it. So there's some issue with the CentOS 7 support. I believe it's a dependency issue with some sort of service that is dependent on CentOS 7 that's not updated on Oracle. So so I think that's what the issue is. So but migrating into Oracle 8 seems to be stable. For now, at least, I don't see any issues at the moment. So Oracle supported software with Oracle supported operating system, I think it's much more convenient in this term. So okay, so the listener is running and everything. So this has been completed. Okay, so that's the listener. So finally, I think one more thing. Sorry, let's go back to this. And okay, so let me reduce that, and let's switch into the Tomcat instance. This is in CentOS Stream, and the previous one is in Oracle Linux 8. And again, I explained this before, why I'm using a hybrid kind of infrastructure. Hybrid reasoning is that, you know, like for example, I'm going to develop a file processor and I decided to go with the Windows FTPS server. The advantage of a hybrid infrastructure is to create layering. You know, you're not dependent on one form of service. So, so like, you know, it creates an environment where, you know, you modularize your failures. Like if something happens in one service, like let's say there's a vulnerability on Java, you know, I have the ability to manage the modularity and dependency at least I know my .NET services are not going to be affected by Java services, right? So something like that to consider. And what I really want to show here is the flexibility of using containerized server instances. Now, the reason why I chose Java, Java is a very interesting. It's a very how do I explain it? Java has been around for a very long time, and is very stable. Java has been using the concept of virtualized machines for a very long time, and even containerization. Something that's not spoken about, but a lot of the modern Dockerized containers and stuff like that are really built off of the framework that Java already uses. So it's kind of interesting to me that Java doesn't really talk about their services being too extreme. They kind of just built it in and just have it sitting there. But a lot of this new concept of Dockerization, containerization of application, Java has been practicing this this entire time. So the beautiful thing about the Tomcat 9 instance is that it's a containerized server, meaning that all I had to do to get this Tomcat instance running was really zip up the folder location of Tomcat, zip it up, unzip it into a new operating system. All I have to make sure is that the Java JVM is installed on the system, and as long as I literally just copy and paste the zip file over and extract it from one application or another, the entire Tomcat instance is retained. So all the configuration that you've done on Tomcats and all the configuration you have done on Tomcat and all these instances of the deployed services, they're going to be contained. Actually, there may be a requirement to redeploy the servers, just depending on the location you put the applications. So that's the beauty of this, and I already tested the connection of the Tomcat instance and everything. It's I think it's looking good. So if it wasn't as slow, I think I can showcase it easy. But let's see if I finally the last thing I had to do was configure the firewall instances. So the firewall instance would tell me if I can connect from another computer. So let's just do a let's just see if I can go into Tomcat. So this is from this machine to the server. And this is the server connecting to itself. So there we go. I can connect to the Tomcat instance, and so the Tomcat is running. This is from my local machine to the server. This is the virtualized machine of the server instance connecting. If I try to connect from here, it's going to connect to itself, basically. And if I go from outside, this is the host server connecting to the virtual machine. So there's a layer of firewall configuration between virtual networking that is configured here. That's been tested. I tested the firewall configuration, everything like that. So there's only required for the dependent services. So okay, this TeamViewer thing is pretty slow, so I'm kind of frustrated with it. Speed of clicking. Okay, cool. Anyway, so basically once I've connected everything, what I've done is I've connected into my test server, and now I'm in the Oracle instance. So the Oracle instance, I created a schema for my data that's going to be inserted from reconnaissance external reconnaissance dumps. So I maybe explained it prior in my previous videos, but this is basically the design template that I'm using for the reconnaissance scans. This is the entity, the schema design. Basically, the whole idea is that reconnaissance allows you to collect many different information, which are separated into CSV files which you extract. Now, the CSV files now can be represented as a data, which can be used to create relations. So so that's what I've done here. The individual data dumps are now related with each column data and stuff like that. So there's a form of relation that takes effect. The whole idea is that I've created two separate data designs. Like I created a table scheme for data dump, and I created a table scheme for viewing data. So like if we look into the data dumps, the data dump is where basically I extract the CSV file data and I just dump it into a table. So this is the data dump. This is so I give it a naming convention. I call it Recon scan dump, and the extension for the kind of data that we're looking into for each table. So companies, contacts, credentials, domain, hosts, leaks, locations, net blocks, ports, profiles, push pins, repositories, and vulnerability. And if I dig in, like the kind of columns we're looking into, we got the kind of data that we can collect from reconnaissance, company description, user ID, etc. And here we have company ID. We have first, last name, email, region, phone for contacts. We have credentials, company password hash, type leak, etc. We have domains. Domain, some notes, some modules associated. We have hosts. Hosts are going to be company ID, location ID, IP address of servers, region, located, country, latitude, longitude, location. We have the scan dump for leaks, which is a leak ID, description of the leak, source references for the leak type, and import leak date, attackers, number of entries, score of the leak, attack, target industries, the password hash, the password types, target media refs, module, etc. We have locations. We have street address, longitude, latitude. It just resolved basically the latitude, longitude into the street addresses and stuff like that. So this is using the GeoIP API. NetBlocks utilizes the net block. I believe it's a a port related with ports. We would call net blocks, or the associated ports with net blocks. So I think there's a relation here that will clearly define what that is. So we have hosts that are associated with vulnerabilities, locations, push pins. Hosts are related with ports. And let's look into net blocks. Profile, repositories, credentials, domains, push pins, ports. Okay, net blocks, it has actually no relation, but it belongs here. Okay, so interesting. I'm gonna save this here. So NetBlock just has a description, but it's not related with ports or hosts, at least not yet. Until I actually dig into the data and find that kind of relation, I'll create one. But we have ports, profiles, push pins, repositories, and vulnerabilities. So these are the kind of information I collect with Recon. And basically the whole idea is that this is my scan dump. I'm going to take the data and dump it into these scan dumps. And from these scan dumps, I'm going to generate view tables. The view tables are going to retain the meaningful information. The whole idea is that the view table is now going to query into the scan dump and create some sort of relation, key constraints for optimization of search index. So like for example, I created two different tables. So one is a scan dump to dump the data, and it has denormalized structure, DDL SQL. So and the view tables contain the the queryable information that is optimized for search index performance, and it retains the restrictions, for example, removing redundant values, and also creating constraints for index improvements, stuff like that. So that's the whole idea. I think more or less what I would convert the views into is materialized views, for the where the views are actually going to take a layer of querying into the scan dumps and removing redundant information, and then materialized view are going to contain indexes to improve the search performance. Okay, so so once we structure the data into the DDL tables, the whole idea is that now I can create PLSQL procedurals that restricts the data, checks the data, runs validation, and is going to query into the table. So like there's two different types of inputs. So like for example, the CSV files, there's going to be a processor that only dumps the data into a scan dump, and the whole idea is only going to do inserts. And when we do the API call to retrieve the data, is only going to look into the materialized views. So that's the whole idea, and it's going to, so scan dumps connects to, runs a store procedure. Store procedure is going to dump the data. As in materialized, so as an API call is going to take the views. So basically, if you're going to request the data, you run an API. The API is going to create a model for the materialized view, and is just going to pull the information from the materialized view into view. That's it. So it retains the best query performance. And inside the query performance, API can also retain catching mechanisms. Excuse me. So okay, so that should be good. All right. So now, so that's what I have in the whole database. This is basically just the script that I created to basically just create the structure of the entity. So this is a pretty long script, but this is going to help build the reconnaissance database. Okay, so the DDL structure for the Oracle SQL reconnaissance database. So this is a long SQL script to create that. And yeah, so this is just retaining the structure. And if I make changes to this if I need to, if I see some meaningful data, I like, for example, I add some properties to create some relation for my my structure. Like I create a scan ID. So like, so when you insert a scan, the scan ID is now going to be created. View contacts. Right here, so scan ID is created dynamically. When we create the table, these scan IDs are going to retain as unique information when this table is created. And now the scan ID is going to be related with the scan that was collected from the reconnaissance, and is going to be dynamically generated with the SQL. So once the data exists, when the row is inserted, is going to create a scan ID from SQL. That's the whole idea here. And then we can query the information, etc., etc. Okay, so yeah, so this is some meaningful information. I create some restrictions to make sure that we're not pulling redundant data, like data that is null or stuff like that. I want to create meaningful data, like that. That's the whole idea. So I created those constraints in SQL on the SQL end. So I'm not running it on an API layer or anything like that. I think the best place to put that into is SQL. SQL handles SQL. Like it's simple as that. All right. So that's the whole idea. That's what I've done so far. That's just a short update. I have a .NET Core process that I'm going to be working on to pick up these CSV files and actually process it, run a store procedure, and dump the tables, like dump the data. And I think more or less this HydraBlend reconnaissance module is going to be almost complete, or is going to see its completion soon. So okay, so thank you so much for the patience. So this is another HydraBlend update video, and if you appreciate these videos, or if you want to follow HydraBlend, thank you. All donations are appreciated, even if it's like 5, 10, 15, 20, whatever you feel is reasonable. That's cool. I would also say that on the release of this module, if you do donate to HydraBlend, the amount that you contribute will be rewarded to you as a user with credit. So like let's say you donate on GoFundMe or my Facebook links or anything like that, I will track the user that donated. Or if you get a receipt, take the receipt, submit it to HydraBlend. When this module is released, you'll have that information, and then I will create your user account with the credit attributed to you to use the services in HydraBlend. Okay, so thank you so much for the support, and appreciate you watching this video. Thank you.